Hello, welcome to week 4 of RX 2010. This week we're going to start a new topic. We're going to talk about allegations, and we're also going to talk about something called parental calculations. So let's look at a couple of definitions real quick. We talked already about concentrations, and concentrations were just the strengths of those mixtures or solutions. Usually you'll see them expressed as a percent, sometimes as a ratio. It's just good to keep that information in the back of your mind because you're going to need those concentrations as percents to be able to do your allegation problems. Now, if you'll remember, we've already done dilutions. Dilutions, we use this formula C1Q1 equals C2Q2, and we basically just added water, added petrolatum, a cream base, something like that to make something weaker. Allegations are a little bit different. However, the allegation grid that I'm going to teach you this evening is something that you can also use for dilutions. So now that we're learning the allegation grid, it can be used for both allegations and dilutions. What an allegation grid, or what an allegation in general does, is it allows you to mix two products together that have different percent strengths, but they have the same active ingredient. So you have something stronger, something weaker, and you put them together and you make something in between. That's why you can also use it for dilutions, because that something weaker is your water or your petrolatum base or your cream base. So let's take a look at how all of these things work together, and let's try a few problems. Okay, here's our first example. We are told that we need how much dextrose 70% to mix with dextrose 5% to prepare 1,000 milliliters of dextrose 20%. So the allegation grid is simply the tic-tac-toe board. So I've drawn the tic-tac-toe board for you. The strength of the solution that you want to make is what goes in the middle. We are trying to prepare dextrose 20%. So that's why 20 went in the center. And in order to prepare it, we need to use 70% and 5%. Typically, you'll see the higher strength in the upper left corner and the lower strength in the bottom left corner. And that's how your book will present it as well. Just so you know, if you switch those around, you're not going to get the wrong answer, but you're going to have to just be careful with reading your grid. And I'll explain that a little bit more as we go on. Okay, so once you've got your percents in your grid, the next step that you're going to be doing is subtracting diagonally. So the first thing we're going to do is take 70 minus 20. 70 minus 20 is 50, and that's going to go down here at the bottom. And then we're going to do the same thing going the other direction. Remember, we always want a positive value. So we're going to take 5 away from 20. 5 away from 20 gives us 15. Now, what these two numbers that we just wrote represent is how many parts of each solution. So we need 15 parts of a 70% solution and 50 parts of the 5% solution. So you're reading across the grid. 15 parts of the 70% and 50 parts of the 5%. So again, we're just reading across the grid. So altogether, if we total these, we need a total of 65 parts. And knowing that total is very important for us to be able to go on and finish using the grid. Okay, so remember we said we needed 15 parts of the 70%. We need 15 out of that total of 65. So we're going to write that as a fraction. 15 out of the total of 65. And we're going to take that ratio and we're going to multiply it by the quantity we want to prepare. In this case, we want to prepare 1,000 milliliters, so we're going to multiply by 1,000. Now, remember, you should always put your fraction into your calculator and hit the equals button, because not all of our calculators are as smart as we want them to be. So 15 divided by 65, hit your equals button, and then do times 1,000. When you do that, you'll see that you get 230.76, blah, blah, blah. Let's round to the nearest whole number. And we're just doing that on this one because that's what I chose. You'll always want to check with your pharmacist to see how they want you to round. So in this case, since they didn't tell us, I'm choosing to round to the nearest whole. Okay, so that is how many milliliters of the 70% that I need. How do I know it's 70? Because again, we're reading across the grid. So that's how many milliliters of 70%. Now, I also need to figure out how much of the 5% we need. So we're going to do the same thing. We're going to take the number of parts, which in that case is 50, and we're going to put that over the 65, because that's how many total parts we have. And we are going to multiply that by the total quantity we want to prepare. And in this case, that total quantity was 1,000. Again, we're going to put that 50 over 65 into our calculator, hit that equals button, then multiply by 1,000. Since we rounded our first answer to the nearest whole, we're going to round this one to the nearest whole also, and you're going to get 769 milliliters, and this time it's the 5% because again we're reading across the grid. Now, one thing that you can do when you complete your alligation problem to check to make sure that you got the correct answer is you can add these two quantities together. So if I add 231 to 769, I should get 1,000 if I did this correctly. So go ahead and stick that in your calculator and you'll see that yes, indeed, we do get 1,000. That's how I know that I set this up in the correct manner. Okay, let's take a look at another one. On this one, we need to prepare 150 grams of a 20% cream using a 30% stock cream and a cream base. Remember I said that you could use this grid for dilution problems, and this is a dilution problem. We're mixing something with a base to make it weaker. So, again, we ask ourselves the same questions. What strength are we trying to make? We're making 20%. So that's what goes in the center. We are using 30% and a base. Base does not have any drug in it. Therefore, the strength is 0. So that's what goes in the bottom corner. Now we're ready to do our subtraction. 0 from 20 gives me 20. 30 minus 20 gives me 10. So altogether, when I add this, I have 30 total parts. 20 out of the 30 are the 30%. 10 out of the 30 are the 0%, the base. We're going to take both of those ratios and multiply by 150 because that's the quantity we want to prepare. Again, put that fraction into your calculator, 20 divided by 30, and hit your equals button, and then go ahead and hit times 150. And you will see that that crazy decimal that you got most likely will come out to be exactly 100, depending on how your calculator handles repeating decimals like that. If not, you got 99.999, which will round to 100. And then we'll do the same thing with the bottom one. 10 divided by 30, hit your equals button, times 150 equals, in this case, 50 grams of the base. Again, in order to check that, we add those two quantities together. And here's my check right down here. I added 150 together to get 150. So yes, this one is correct also. Okay, here's our next one. We received an order for 40 mils of a 4% solution. In stock, we have a 1 and a 6%. So, using the grid, we put the 4 in the middle because that's what we want to make. We're using 6% and a 1%. So we're going to subtract. 6 minus 4 gives me 2. 1 from 4 gives me 3. So that is a total of 5 parts. 3 out of the 5 are going to be 6%. 2 out of the 5 are going to be the 1%. Take both of those ratios times the quantity we want to prepare, in this case 40, and you're going to get 24 mils of the 6%. And remember, the way we know what it is because we're reading across, and 16 mils of the 1%. Adding those together to check, 24 plus 16 does give me 40. So I did get this one correct as well. Okay, we have a few other alligation problems that are just a little bit different. The next one I want to show you has ratios in place of percents. So the first thing you're going to want to do is to take these ratios and change them to percents. Remember, to change a ratio to a percent, we're going to divide the top by the bottom and then multiply by 100. So we did that first. So I changed each ratio to a percent. Once I did that, then I went and put the percents into the grid. It'll make things a ton easier for you. So the 1 to 5 is what we were preparing. That's 20%. So that's what goes in the center. We're using a 1 to 4 and a 1 to 10. So 25% and a 10%. We're ready to do our subtraction now, just like before. 25 minus 20 is 5. 10 from 20 is 10. So we have a total of 15 parts. 10 out of those 15 are 25%. 5 out of the 15 are 10%. We're going to multiply both of those by the quantity we want to prepare, and then we will get our final answer. 333 of the 25%, 167 of the 10%. Checking our work, we add these two together, and when we do, we find out that 333 plus 167 does indeed give me 500 milliliters. We'll do a few more practice with the ratios when we return in the second segment.